Bakelite resinoid, a resin-like substance and the basis of all Bakelite products, is manufactured by mixing phenol, a coal tar product, and a solution of formaldehyde and subjecting them to heat. A violent chemical reaction takes place, resulting in the liquid separating into two layers. The upper layer is removed, while the lower, when cool, forms the resinoid, which, when broken up, appears in this form. At this stage, the resinoid can still be melted by the application of heat, or will dissolve in certain solvents. A further application of heat makes the resinoid incapable of being melted, and it also becomes insoluble. It is these characteristics, not possessed by natural resins, which have made possible the development of the modern plastics industry. The raw materials used in the manufacture of Bakelite resinoid, such as phenol and formaldehyde, are stored in large tanks from which they flow to the measuring room by gravity. It is essential that all materials should be subjected to careful analysis and control constantly exercised. A measured sample of cresol is distilled under standard conditions so that percentages which pass over at different temperatures may be established. The purity of the phenol is tested by freezing, so that the temperature at which it solidifies is noted. The standardization and purity of the raw materials having been assured, they are drawn to the stills by vacuum pumps, where the manufacture of the resinoid is carried through. The hot resinoid is then discharged into trays, where it remains to cool. Varnish produced from the resinoid is tested to ensure the correct standard of viscosity, its most important characteristic. Resinoid forms the basis of paints, varnishes and lacquers, which can be applied by spraying as well as brushing and dipping, and are notable for industrial, marine and domestic purposes on account of their durability and quick drying properties. The principal application of Bakelite resinoid is in the manufacture of molding materials. After the resinoid has been ground to a fine powder, fillers such as wood meal or fabric, as well as dyes and pigments are added. These are microscopically examined and subjected to a screening analysis before being used. quantities of these ingredients are now fed into giant drums, where they are mixed with a thoroughness which is not left to chance, but established by the taking of test samples. For test purposes too, the manufacture of moulding material is carried out on a small scale. The ingredients are weighed out and mixed. After which, the mixture passes over heated rollers where it is needed and transformed into a plastic sheet which becomes brittle on cooling. This is marked for laboratory reference. In the factory, the same process is carried out, although of course on a much larger scale. Thorough kneading, and then over a cooling conveyor where it hardens. The brittle sheets are then ground up, and separators and screens remove both the fine dust and oversized particles. To obtain uniformity, the material is bulked, and after weighing is packed in drums for dispatch from the factory. Once more, however, a sample from each drum is taken to ensure that Bakelite moulding materials as sold comply with recognized standards of quality. These standards are maintained by certain tests, one of which is the cup flow test, approved by the British Plastics Federation. Another test by which the amount of resinoid contained in the moulding powder is ascertained. This test is also used to ascertain the state of cure of finished moulding. Tensile strength and good dielectric properties are other important factors in Bakelite moulding material, which are established by tests. Another Bakelite product is laminated sheet material. Paper or fabric is impregnated with dissolved resin and passed through a drying chamber to remove solvents. Pieces of definite size are then cut. And stacked between highly polished metal plates. This pack is subjected in the press to both heat and great pressure, and when removed, forms a sheet with a highly polished permanent finish, which requires no further processing and is ready for use as veneers for furniture or paneling of all kinds. Laminated sheet material is resistant to both heat and moisture and impervious to most acids and mild alkalis. Uniformity of thickness is quickly ascertained with the aid of an indicating micrometer, while the ability of the material to withstand crushing stresses is established by a compression test. Laminated sheet material is employed in the production of gears and gear wheels, which necessitates that it should be resilient and highly resistant to bending, and this is controlled by a special testing apparatus where weight is increasingly applied by metal shot. Laminated material is also used extensively in the production of insulated components by the electrical industry and must therefore be resistant to electrical breakdown. The possession of this characteristic is established in a dramatic manner. Laminated material can be molded in simple forms, as for example in the making of trays for domestic use. It can be machined to the highest degree of accuracy, and this factor, combined with its resilience, makes it desirable for silent gear work. When subjected to a steady load, Bakelite gears are actually less liable to wear than steel and have been known to outlast their metal counterparts. Similarly, this material is easily worked by machine tools, and the ease with which suitable thicknesses are punched makes it particularly appropriate for the production of electrical equipment and telephone exchange components, which you see here being manufactured and assembled at the works of Ericsson Telephones Ltd. The installation of one of the largest telephone exchanges recently completed involved the use of over 4 million laminated components. Many thousands of different articles in everyday use are today produced from Bakelite molding powder, which we saw in process of manufacture. A measured quantity is poured into a heated mold, which is then closed and subjected to a pressure of about 1 ton per square inch. In a few minutes, even a large article like this hairdryer is produced. To facilitate the loading of certain types of molds, the material is compressed into pellets. In the Witten molded insulation works of the General Electric Company, pellets are used in the production of lamp holders, a large number of which are molded at one time. An ingenious method of molding the screw thread and so obviating laborious machining is another example of the high degree of efficiency reached in the manufacture of Bakelite molding. This method is also used in the manufacture of a vacuum flask casing. The finished article is unscrewed from the mold and is immediately ready to receive its base without further processing. studio cabinets in one complete piece with a highly polished finish are produced at one time as easily as a large number of smaller articles like the familiar hand microphone with its internal connections already in position before molding takes place. The production of electric torch cases provides another use. In the De La Rue molding factory, the molding does not confine itself to plain undecorated surfaces. An elaborate pattern such as has been designed for this tabletop presents no difficulty. Developments of this idea will readily present themselves to the mind. The comparative ease with which mouldings are produced does not perhaps suggest the importance of the actual mould. The provision of moulds constitutes a high initial capital outlay. The highest craftsmanship is required in the manufacture of moulds, and some interesting devices are employed in the tool room of Moulded Products Limited. In this Keller machine, for instance, the cutter follows exactly the path set by the tracer on the contour of a plaster cast. Another ingenious method, where a number of identical molds are required, is the pressing of a hardened die into a soft steel blank. The resulting impression can then be hardened to withstand the high temperatures and pressures encountered in subsequent use. Moldings leave the molds with a slight flash or fin corresponding to joints in the molds, and this is removed by various methods. In the case of small articles, a large number are dealt with at one time by the rotating action of a tumbler barrel. Larger articles are trimmed by a rotating file. While holes are freed from the flash in this way. Under special circumstances, buffing is resorted to in order to remove all traces of the fin. Bakelite is one of the most remarkable developments in recent times. There are countless uses to which it can be put, as for example in motor car accessories, building trades, and the electrical industries, especially in the latter as an insulating varnish oil. Its applications are infinite. Sports goods, musical instrument parts, and toys are well finished and cheaply produced, as well as highly technical scientific instruments and apparatus. Containers and bottle caps are now molded from Bakelite materials, as are many household requirements. Each day produces a new idea for its use, and this Gestetner duplicating machine illustrates one of the more recent. So many things in daily use, both in the office or home, are made of Bakelite, that it is interesting to witness a few everyday occurrences and realize what might otherwise pass unnoticed. Many articles on a modern dressing table are manufactured Bakelite, and this is also true of office and desk requirements. The fittings of a handbag tone with the color scheme and are light and cannot tarnish. Yes, and the door handles. Notice the safety razor and soap holder. It's cement. Here in actual use is the hair dryer we saw manufactured. At home, we switch on the radio in its shining molded case and sit down to pass a pleasant hour at dominoes. No ordinary dominoes these, Bakelite too, as they are evidently anxious to tell us.